Hello everyone, hopefully you're doing well. In this video, we're going to continue with chapter 6, normal probability distribution. If you missed the first section where we do a brief introduction of standard normal distributions, I strongly advise you to go back and watch it. In this video, we would focus most of all on the section 6.2, real applications of normal distributions. Would develop the ability to describe a normal distribution, not necessarily a standard normal distribution, but find the probability of some range of values in a normal distribution. Find X scores corresponding to regions under the curve corresponding representing a normal distributions and solve real problems using skills. That's mostly what we're planning on doing in these sections. As we do in each sections, where we go over some key concepts. Most of the preceding sections um, deal with the real world applications of bone density scores. That's what we did in section 6.2, which have a normal distribution with mean 0 and standard deviation equal to 1. However, it is rare to find other real application of standard normal distribution. We now extend the methods of previous sections so that we can work with a non-standard normal distributions, which is like mean 0 and standard deviation 1, right? So for us, the key is that we can use a simple conversion that allow us to standardize any normal distributions. Remember, I told you about this formula at the beginning, but we didn't use it. Any x values you have, you can convert it into z, then go back to the table. The same way, if you want to know what x, once you know a certain probabilities, if you solve here for z, remember you can multiply both sides by 1 over z, so you're gonna have z sigma equal x minus the mean. If you add the mean to both sides, you see you can also solve for x. So that means the same way you can find z knowing x, you can also find x knowing z. So it's either way you can use it, these two formulas. I strongly advise you to put them somewhere because we're going to use them a lot. So here it is, the formula. We said conversion formula. Any x you have, you can convert it into z, because in any problems you're going to have the mean and standard deviation would be given. Remember, this is the population mean, all right? And this is the population standard deviation, right? So you can use these two to convert any x given to z. All right. So very, very important. The formula allows us to standardize in normal distribution so that x values can be transformed to z-scores. But once you know z-scores, I'm going to go back and show you this table we used before, because once you know z, you can use that table to find the corresponding probability. So this table is like moving forward now for this chapter and the following chapter, you're going to use that table a lot. So and what we mean, either you are on the left or on the right. Remember what we do for the tables, you either need to convert x to z. So any values you have, you can do it on the left, or you also can do it on the right, right? So it all depends what it tells you. If it says greater than, no more than, at least, at most, less than, you need to decide which one it is. So the figures, here, the figures illustrate the conversion from a non-standard to a standard normal distribution. You take any x, you convert it to z. Remember, this is x here. Then you can convert it to z. So once you know the z, the area is in any normal distribution bounded by some x is the same as the area bounded by the corresponding z-score in the standard normal distributions, right? Very important. Procedure for finding areas with a non-standard normal distribution. You need to sketch a normal curve, label the mean in any specific x values, and then shade the corresponding area. If you use Excel, don't forget its norm.distance function to find the area of the shaded region. This area is the desired probability, but if you use the tables, remember that table, because in this video, I'm going to focus on the table instead of using Excel, because Excel would be in a different in a different one. So make sure we do that. So for each relevant value x that is bounded to the shaded region, use the formula x equal z equal x minus the mean on sigma to convert that value to equivalent z score. Next, use that table to find the area on the shaded region. This area is the desired probability. Let's say it very quick in the examples. What we mean, remember, these values here, we call it's an x value, because remember, it cannot be a z, because z is like, we're not going to have that big number, because it's a find the area on the shaded. So first of all, remember, you must convert any x you have into the mean, into z. First of all, you need to read your problems and verify if x, z, and sigma is, oh, they said mean is 100, standard deviation is 15. So meaning we know the mu is 100 and standard deviation is 15. Remember in the problem I said that you would always be given these two. So if you know x, this is x right here. So meaning if x is 118 minus the mean, which is 100 over 15. So we know that z, because our goal is to convert any z. Remember, we're going to convert any z to we're going to convert any z x to z, right? We're going to convert any x to z. So 150, 118 minus 115, answer is 1.2. Okay, 1.2. And look at this shaded area. Are you on the left or on the right? We are on the left. So that means if you're looking for the probability that z is less than 1.2, okay, remember you will need to take exactly what you find in the table. So this corresponding table I put here, let me bring it down here for you so you can see. Remember, if I make it a little bit bigger, 1.2 for z, okay, what is 1.2 for z? This is 1.2. 1.2 mean 120. So we know we need to take the intersection of these two, which is 0.8849. 0.8849 is the answer. 0.8849 is the probability we're looking for. Right? Now, because we use the same mean mu, remember this is the mean is 100 and the standard deviation is 15. So if you here also you want to convert, remember here x is 91. If you do 91 minus 100 over 15, what z would be, because we use the same exact formula. Remember the formula for us is z equal x minus the mean on sigma. We would always use this formula to convert any of these corresponding ones. So doing this, answer would be negative 0.6. Now, because we are on the right for that one, so probability that z is greater, because it's on the right, negative 0.6. The first thing to do is 1 minus, because anytime we do greater than or we are on the right, we must subtract the corresponding probability from 1. So negative 0.6, this is negative 0.6 here. If we put it, this is the one give you negative 0.6. So 0.2743. So what would be the corresponding probability when we do that? 0.2743. If you subtract, I believe it's gonna be 0.72. 27, right? Okay, you tell me, one minus that would be, let me do it with calculator instead. So let's see, it's gonna be one minus point 2793, right? That's what we find from the table. Let's try again for the table. The table for 43. Oh, 43. Sorry. Yeah, that's 43. I put point. No, 1 minus point 2743. Yeah, point 7257 would be the answer, right? So this is a 43. All right. So we need to make sure it says 43. Again, the next one, as you can see, you have two values for x. Okay, so remember this here you have x equal 79 and x equal 132. So the first thing to do is to convert the first x to z. That means 79 minus 100 over 15. That's the first z. So what this z would be, because we need to convert each of them separately, all right? So can we, looking at that, it gives you negative, we do 79, yep, negative 1.4. Now, if you do the second z, I'm gonna put it there. We do 133 minus 100 over 15. Answer would be what? Because when you do 133, that gives you 2.2. Okay. Now remember, when you do between, that means probability that z is between negative 1.4 and 2.2. We said when you do between, it's better you will write it as z is less than 2.2 minus probability that z is less than negative 1.4. 1.4. So find from the table 2.2. What do you see for the table? 2.2 is this one right here, right? Negative 0.98. It is 0.9861. And negative 1.4. Okay. Negative 1.4 give you 0.80808. And 0.808, I think that's what we need to find. When we subtract them, it gives us 0.9053. Remember, I do it using the tables. You can use it using Excel or TI-83, TI-84. Remember, I gave you some formulas on how you can proceed using either Excel or TI-82, 83 or 84. But at the same times, you need to make sure that if you use technology, make sure you do it properly. Okay. So, in the calculator, don't forget to do normal CDF or normal PDF with, or you do inverse normal to find the probability. So these two, we're gonna have some videos on it and to make sure that you do it properly. Now, next, what I want you to see here is how you can find values because when you find the area, like we did here, okay, oh, we have one more, but remember the one more, it's also between. Remember here, if you use a calculator, as I said, you need to do the normal TI 83, 84. You need to do the normal CDF, right? Don't forget to do the lower X, upper X, lower X, upper X, and you have the mean and the standard deviation using your calculator. All right. Now, what I want you to understand also in these sections, I mean, sometimes we can ask you to find the values instead of finding the probabilities. Let me reduce this slide so you see what I'm finding values. When we're looking for values, that's what I said. When you look for values, because when you have z equal x minus the mean on sigma, you can solve for x. If you solve for x, then the answer at this point would be x equal the mean plus z times sigma. So we can also solve for values knowing the probabilities. We do the inverse of it. So that's helpful hence for those cases in which the area or probability or percentage is known and we must find the relevant value x. I'm going to put x for you to remember. Graphs are extremely helpful in visualizing, understanding, and successfully working with normal probability distribution. So they should always be used. Don't confuse z-scores and areas. Right? Areas, remember, it's probabilities under the curve. Z-scores are distance along the horizontal scales. That means for us, when you have the horizontal scales like this, under the normal curve. Remember, the z-scores would be probably here. The z-scores is there, like the critical values is on the area like this. All right, but areas are regions under the curve. So for us, this is the area. So area for us is this one. So we call this one area. And those are z's. Okay. So don't forget to do that. And table A2 lists z-scores in the left columns and across the top row like we did, but areas are founded in the body of the tables. Please review the tables we just give you right there. Okay, so usually I type, I put the table again for you to see right here in the middle. If I clean it, what we said that, you know, uh, z-scores on the left, the first column, of course, or the top. Choose the correct right left side of the graph and values separate the top 10% from the others will be located on the right side of the graph, but a value separating the bottom 10% will be located on the left side. And again, to find values from known areas, z-scores must be negative whenever it's located in the left half, that means below 50%. Areas are always between 0 and 1, and they are never negative. Remember, you cannot say the probability is negative. Procedure for finding for finding values from knowing areas, sketch the normal curve and enter the given probability or percentage in the appropriate region of the graph and identify the x values being sought. If using technology, refer to the instruction at the end of the section, right? So we use usually, TI-84, TI-83, or Excel. If you're using the tables, then we're gonna do it together here and you would see. Remember, I said this is how you need to proceed to find the x values, and this one is come from the z equal x minus the mean on sigma, where we solve for x. So if you remember a little bit of your algebra, you should be able to solve for x. Okay, refer to the sketch, to do that. Now, this is some for examples. At this point, would you say you are on the left or on the right? First of all, remember, this is the area. you need to find the corresponding Z. So if the area is the probability is 0.99, what would be Z? Okay, for this one. So look at the tables. I'm gonna bring the table back down here. You must look inside of the table. We must identify 0.9918 or the closest value, 0.9918, because it's positive, is below 50%. So we know, oh, sorry, it's below 50%. We know it would be somewhere in the first, on the left side of the table, which is positive. Okay. So what we're gonna do then here, all right, for that one, let's try because you're gonna like it. Okay, so we're gonna see where we see 0.9918, 9918, 99. Oh, right here. I'm hoping you see it. This is 9918. That means 2.4. 9918. Okay. The Z is 2.40. It is 2.40. Let me check that. Okay, we have 2.40. Okay. Now, the questions, you must read the questions first. Find the indicative IQ score and round to the nearest number. So remember, they asked us to find X when sigma, when the mean is 100 and the standard deviation is 15. So we know from here the formula to find this one is X equal the mean plus Z sigma. So X for me, that value would be the mean 100 plus 2.40 times 15. So X for me, when you do that from your calculator, because let me do it with my calculator, 2.4 times 15 plus 100. That's 136. So this is how we're gonna find the X value. So you see, we can do it. But here would be different because we are on the right. When you are on the right, you should always subtract from 1 the probability found. So when you do 1 minus this, probability would be let's do 1 minus 0.1587. It's 0.84. 8413. 0.8413, okay? 0.8413, this is the this is the probability. Now, what Z correspond to this probability? That's what you need to find. So the Z correspond because they ask us to find X value. Remember that one. So the Z correspond to this one. You go again in the tables. When you go in the tables, you need to look for 0.1587. Where is 0.15? Because 15 means, no, not 1587. Sorry, what's we find again? 0.8413. 0.8413, that means we are on the right side of the table. 84, let me put it smaller because it's too big for me to do that. Okay. 8413. 84. Is that this one? It's not exactly 1. See? Yeah, it's 1. So meaning Z is only 1.00. So remember, when you look for x, x would be mu plus sigma z, like this, or you can write it either way. So we have 100 plus 1.00 times 15. So you understand x would be 100 plus 15 is 115. So easy, easy for that one. Remember, if you are on the right, always subtract from 1. That's what we said. If you subtract this number from 1, okay, because you are the only times you do that is anytime when you are on the right. Point 97, 98, give you point O2, O2. Now, you go in the tables. This is the probability. O2, O2 is the probability. What Z correspond to it? Because it's a very small number, we know at that point, it's going to be definitely on the negative side. Let's see, point O2, O2. Right, I see it here. You need to look for it. So always check what Z give you this probability. Okay, O2, O2 is 2.05. Okay, hold on. Negative 2.05. Now remember, X for us equal the mean plus Z sigma. So meaning it should be 100 plus 15 times negative 2.05. So when you do everything, remember you do 2.05, which is negative times 15 plus 100. So it's really give us 69.25. 69.25. Remember, probability is never negative. Probability, the probability never negative. All right. So I leave the last one as always. I'm hoping you enjoyed this, but let's focus most of all on our next examples because we have a few examples to do very quick. In this one, if I reduce it a little bit, they said use the data in the table below for polls, for polls rates of adult males and females. So, those data are from the book. Of course, you see it's based on data set, but that you would find in the appendix B from the book. You usually said draw a graph in each case. So we're gonna see it. Let's say I'm gonna do probably one or two, but look at the probability because for me, in A, if I do A here, I see they do do find the probability that a male has poles less than 60. Remember, it's symmetric about the mean, that means 69.6 is it? So less than 60 would be probably 60 is somewhere here. So this is the area we're looking for. And because we're looking for probabilities, that means first of all, we need to convert that X value to Z, because for us here, X is 60, right? So when you do 60 minus the mean, remember this is the mean for male, and this is the standard deviation for male, the mean for female, the standard deviation for female. So 60 minus 69.6 over 11.3. What that, first of all, we need to find what this one gives us is 0.85, negative 0.85. Okay. All you need to do, because we are on the left, the probability that Z is less than negative 0.85, go in the table and take exactly what you find. Okay? Exactly what you find, because let me do it, 60 minus 69.6 divided by 11.3. Yep, it's 85. We take only for 2 digits, make it, otherwise we need to extrapolate, something I don't like doing. Okay, extrapolate. Now, you see, you need to go to the table, that beautiful table I set up for you here. I'm gonna put it down here. All right, let's clean it a little bit. You're looking for negative 0.85. Negative 0.85. Okay, negative 0.85. Negative point 85. So that should give us 0.1977 to the left because we are on the left. So we are on the left. It gives us point um, 1977. So this is part A. Okay? If you want to do B, I can do B, but it's still the same thing. To show you for female would be different. If you do B for female, okay, B for females, remember we're gonna do 60, like we are on the left because it said less than means less, you are on the left of 60. So if you convert 60, remember minus the mean for female 74 over 12.5, what Z corresponding would be for that one, the Z would be negative 1.12. Now that I know, I can do, because we are still on the left, Z is less than negative 1.12. Okay? What you're going to find in the table, because here, X again is equal to 60. So what would be in the table for negative 1.12? We go negative 1.1. Make it 12 would be here, right? So 0.1314. So probability never negative. So that's how we do left. I can keep the same one and probably go down because we don't have enough space to do everything. Let's suppose here I'm gonna do only one. Let's do only one. We're gonna do, now you see how I do it. I don't need to do male and female each time because now what they ask us to do from C, in C, find the probability that female has greater than, this is greater than, now we are on the right, greater than 80. Suppose 80 is here, that's X values. Okay. Now all I need to do, convert that X using the mean 74.0 over 12.5. Okay. So female greater than 80. For this one, it gives us 0.48, positive 0.48. Now, what we need to do, remember, in this case, we are on the right. So probability that Z is greater than 0.48, the first thing to do, whatever I find from the table, I need to subtract it from 1. Now, going to the table, I'm going to find 0.48, zero point 0.4, and going all the way to 8, right there. 0.6844. 0.6844. Of course, you can use technology also to do it. If you use technology, that would be fine. It's 0.3156 to the right. 0.3156 is the answer. Okay. Now, look, if you decide to go with a different ones, like, we do, I think I do C. Let's do between. We're gonna do a between. We're gonna do between anything we want, right? Let's do male between. Let's do F. Because if I do one, I'm pretty sure you can do the other ones. Now, the goal for doing F, first of all, this is our normal curve. That would be done between 65 and 85. So we're gonna do between this area right there. First of all, you need to convert each of them. Let's call, sorry, let's call the first Z, Z1. So where we're gonna take 65 minus, we're doing male. Remember, we're doing male. What's the mean for male? 69.6 over 11.2 because we're dealing with male. What that Z would give you, because we do 65, let's see which number it is. Um, so it would be 65 minus 16, negative 0.41. Now let's do the second Z as 85 minus 69.6 over 11.3. Remember, we're doing for male. To do for male, 85 minus that gives us 1.36. Now, remember, when you do between, when Z is between negative 0.41, 1.36, you should put the largest one first. Z less than 1.36 minus probability that Z is less than negative 0.41. Now, what's probability from the table for 1.36? 1.36. So that will be 9131. Minus whatever you find for negative 0.41, negative 0.41, okay, 0.3409. What's the probability then? Okay, so 9131, 3409 give you 5722. Okay. Here you go. So that's how we do it, but I will definitely leave the other ones for you to try because that's how we're gonna do it. The other examples from this section, I can either do it or look at this one. We have the mean and the standard deviation for each of them. Remember, the mean here is 68.6 and the standard deviation is 2.8. From female, mean is 63.7. Standard deviation is 2.9. Remember, always write somewhere these two formulas that you would probably need. Z equal X minus the mean on sigma, or if you're looking for X is equal the mean plus Z sigma. So it's all depends what they ask you to do because they use these parameters. Now, Navy pilots, the US Navy requires that fighter pilots have height between these two numbers. They give you between these two numbers. That means you have X is between 62 and 78. So for us, first of all, you have two Z's to convert. So you need to convert the first Z. That means 62 minus the mean for. Hold on. Because all guys that fighters have 50% of female. Oh, we need to do female. Now, women, not men. Find the percentage of women required are women not qualified because they are too tall. So we're not using the male here. We use even though these informations are given, but they don't access. We're gonna do it for female. So we're gonna do 62 minus the mean for females, 63.7 over 2.9 for female. We're doing only female. So what this Z would be, because we need to do these examples using the Z. Let's see what my calculator would give me. 62 minus 63.7 divided by 2.9, negative 0.59. Let's do the second Z. We have Z2 equal 78 minus 63.7, because we do only for female in this case. So doing this from your calculator, it gives you 4.93. Oh, that's amazing. Look at something. Remember, to find this, we're going to find probability that Z is between negative 0.59 and 4.93. Okay, that means probability that Z is less than 4.93 minus probability that Z is less than negative 0.59. So, very important. If you look at in these tables, all right, from these tables, you don't have 4.93. You see, we go all the way to 3 point something. But the good news, we said if you get anything greater than 4.93, 4.50, it is 0.999 or 249. Or you can do one if you want to, but we're gonna do 9 4 times, because for this one, the area to the left, if it was to the right, it's gonna be 0, but to the left, to the right, it's gonna be 0.0001, but to the left, it's gonna be 0.99999. To the left would be, okay, 0.9999 minus anything you can find for negative 0.59. Let's go for negative 0.5. Where is 9? On the last one. 0.2776. 0.2776. If you subtract these two numbers, subtract these two numbers, it gives you 0.7223. 0.7223. This is that very important probability, 72.23%. And the questions they ask for this one, they said, find the percentage of women, they said the percentage of women, what again? The percentage, yeah, the percentage of women meeting the height. So you can see here the percentage is 72.23%, right? Are many women not qualify because they are too short or too tall? Well, look at that. 72. The average is what? For women, 63.9, right? But they ask them to do between 62 and 78. They are qualified, right? Yes, about 28% of women are not qualified because of their heights, because you only have like 72% that would qualify, because 28% are not qualified, right? Not all women qualified in this case, you know. Next questions I will probably leave it. If the Navy changes the height requirements so that all women are eligible, except the shortest 3% and the tallest 3%, what are the new height requirements? So Again here, the z-scores of 3% values to the left, you need to check in the tables to see 3%. 3%. Remember, 3% is 0.03. What z corresponding to 0.03? Okay, 0.03 make it 3%. Is that correct? The z for that, I'm gonna use this one. 0 point. Let's erase a little bit because I no longer need these. And I am in the negative side of the table. Okay, let's try it. We need to find it 0.03. Right there. Yeah, I find it. That's give me 1.88. Negative 1.88. Remember, we said 43%, negative 1.88, that's a z. Okay. So if we said negative 1.88 for z, okay, you can check it. Okay. For me, what b would be, remember x is mu plus z sigma. So that means the mean for female is 63.7 plus negative 1.88 times sigma, which is 2.9. Let's see. Women that won't be qualified, we're gonna see it. We do 1.88 negative times 2.9 plus 63.7. 58, right? It will be 58.2. That's the lower one. Now let's go for the taller one. Remember, it's taller means you need to do 1 minus 0.03. That gives you 0.0, 1 minus 0.3 give you 0.97 on the right, because now what z correspond to 90 is to this one. Remember, z 0.97. It's gonna be exactly the same thing right here. 97 is this one. Is this one here is 1.88. Okay. We know it's gonna be 1.88 positive. So the other one, x equal 63.7 plus 1.88 times 0.29. What it's gonna give you at this point, 74.1. So the questions asked was, if the Navy changed the height requirement so that all women are eligible except the shortest 3% and the tallest, what are the new height requirements for all women? New height requirements would be 58.2 inches to 74.1. Okay, so that would be it. Okay, all right. We have a few other questions, and I would leave it for you because, as I said, I don't want you to one. Actually, that would be exactly the same questions for this one that I would leave for you. But let's see. Another thing is very important to do in this section. Engineers must consider the circumference of adult heads when designing motorcycle helmets. Adult head circumference are normally distributed with a mean. We have the mean 570 and a standard deviation 18.3. Remember, whatever they ask you, you either use x minus the mean on sigma, or you use the other one, z, okay, or x equal z plus, I know, the mean the mean plus Z sigma. Now, what they ask you, remember you have the mean and the standard deviation. Due to financial constraint, the helmets will be designed to fit all adults except those with head circumference that are in the smallest 5% or largest 5%. So find the minimum and maximum. We do exactly what we just did. Smallest 5%. Remember, 5% means 0.05. Looking for that probability, Z corresponding to that probability. If we go with the table that I'm going to put down here for you to see, if I remove everything, okay, let's see 0.05, where 0.05 is located. So remember, we're looking for 0.05 would be, it's either here or there. So meaning, this is what they said. When you have something like that's the good thing with that table, it tells you if you have 0.5 falling exactly in the middle, remember 0.05 right here, 0.05. They said it's better you take for Z negative 1.645 instead of taking negative 1.64 or 1.65, take negative 1.645. Now, the top 20%, remember top 5%, uh, top 5%, remember if you are on here and they said top 5%, you need to do 1 minus 0.05, point minus is 0.95. And if you do that, the Z would be 1.645 because you can look in the table and verify 0.95 in the positive side of the table, 1.64, because it's gonna be either here or here, because you cannot take 0.64 or 65 because the distance are the same. You take the in the middle, they said take 1.645 instead. Okay, now that you know both of them, you know the Z. So X here equal the mean plus Z sigma, meaning the mean 570 minus 1.645 times 18.3. So what the X1, I'm going to call it X1. What the X1 would be in this case, okay, that would be 539.9. 539.9. And if you do X2 here, the mean plus sigma Z, or whatever however you want to write it, plus 1.645 times point 18. All right, I need to erase that. 18.3, right? So X2 would be another number, which is 601 millimeters. So we know the answer. What's the maximum and minimum? Max, mean and max are 539.9 millimeter and 600.1 millimeter. That's how you do it. That's how you do it. I think we're gonna do one more exercise in this one before we move to the next sections, which is 6.3, sampling distribution and estimators. So let's do that one. For these particular examples, they said the lengths of pregnancy are normally distributed with a mean 268 days and a standard deviation. Usually we love putting the mean like this and standard deviation 15. Okay. And standard deviation 15. In a letter to Dear Abby, a wife claimed to have a birth 308 days, okay, after a brief visit from her husband who was working in another country. Find the probability of a pregnancy lasting 300 days or longer. Remember for this one, We call it Dear Abby. I'm hoping you like these examples. Very beautifully beautiful, right? Um, let's see. Um, do we do this one in a letter, Dear Abby? Yep. All right. Let's see it. First of all, what you need to do in this case is to convert. We must convert it because x is 308. Remember what z is x minus the mean on sigma. So if we do for a, uh, convert that x values 308 minus the mean 268 over the standard deviation. What is z in this case? Z is 2.67. Now, probability, remember, we are on the left or on the right? Because they said 300 or 8 or longer. That means it's like is greater than 2.67. Now, because it's greater than, we need to because it's all longer. That means we need to subtract from 1. Go in the table. What's probability for 2.6? Go all the way to this is 7. 0.9962. 0.9962. If you subtract, I'm gonna do it, 1 minus 0.9962, 0.0038. Probability the guy is a father of that son, of that kid, is 0.38%. Is that correct? Like we said, the probability of a pregnancy lasting, the probability of a pregnancy lasting, 308 days or longer is 0.38%. Okay? Look, how many days is this? How many months? Let's do 308 divided by 30 days to see how many months. It's like 10 months and a half, almost 10 and a half. Poor, that's, she was at her husband's place in a different country 10 months ago. Now, probability that the kid is she gave birth after 10 months and a half, almost a half, right? Um, is 0.08. Now, what they ask you to do, find the probability of what does the result suggest? Well, can I leave this one for you, or you need an explanation from me also? Because this is either a rare event at some point, or the husband is not the father, right? Rare event, okay. The husband is not the father because it's 10 months. These kids come very late. But let's see for B. They said if we stipulate that a baby is prematured, uh, if the duration of pregnancy is in the lowest 3%, find the duration that separates premature baby from those who are not. As I said, for this one, we need to find it 3%. Remember, if you do the lower 3%, because we did it before, 0.03, what z corresponds to this one is negative 1.88. If you don't remember it, we can always look for negative, 0.03. Right there. You see what z gave it to is negative 1.88. Okay. So that's why, because we did it before, that's why I write it. Now, again, if you want to find this one, x equal the mean plus z sigma. So meaning what's the mean? 268 minus 1.88. Like here, x would be In this case, in this particular case, X would be 240 days. Okay. If the baby born now like this, it would be premature, all right? Because usually it's 268 days. So 240 divided by 30 days in a month. So it's usually 8 months. So we're gonna say premature. You know that some kids born also 6.5 or 7 months with no problem. Hopefully you enjoyed this section. Of course, we're gonna come back with sampling, distribution, and estimators in section 6.3. Have fun. I'll see you in a different video.